Let's check out question number 9. A helium nucleus has 2 protons and 2 neutrons. How many electrons does it take to equal the mass of a helium nucleus? So this is question number 9. Okay, so I'm just going to write down the values of the masses of protons, neutrons, and electrons. Okay, so if you compare these 3 masses, you'll notice that the mass of the proton and neutron are practically the same value. And on the other hand, your mass of electron is way smaller. So what makes every element unique is that they all have different numbers of protons. So in the case of helium, the question says it has 2 protons and 2 neutrons. So let's calculate the mass of a helium nucleus. I'm just gonna write mass of helium nucleus, and then I'm just going to take our different masses of protons and neutrons and then multiply it by 2. So even though they're the same value, I'm just going to separate the 2 just because it's good practice. Okay, so then when we simplify this, it's the same thing as writing 2 times 3.35 times 10 to the negative 27 kilograms. Then we can calculate the mass of our helium nucleus to be 6.69 times 10 to the negative 27 kilograms. Okay, so now for the part of the question, how many electrons does it take to equal the mass of a helium nucleus? So we can have X, so what we're looking for, is equal to the helium nucleus mass over the mass of 1 electron. Okay, so subbing these values in, I'm going to put the 6.69 times 10 to the negative 27 that we just calculated, all divided by the mass of one electron, which is the 9.1 times 10 to the negative 31 kilograms. And then when we calculate this, we end up with a value of 7.4 times 10 to the 3 electrons. Okay, so let's see the answer from our junior tutor. To determine, calculate the number of electrons required to create mass equal to the mass of a helium nucleus. Answer, the number of the electrons required to create mass equal to the mass of a helium nucleus is... There's no actual values in the question. But it looks like they're talking us through how to answer it. Maybe they just didn't have the values of the masses of protons, neutrons, and electrons. So I'm just going to write it down. So bear with me. I have to type this all out. Okay, so I said that given that the mass of proton is equal this, the mass of a neutron is that, and the mass of the electron is the 9.1 times 10 to the negative 31. For helium, the mass of the nucleus is 2 times 1.67 times 10 to the negative 27 plus the same thing. And we get the mass of the nucleus. For number of electrons, it is... I think I'm double checking this. 6.69 times 10 to the negative 27 kilograms divided by 9.1 times 10 to the negative 31 kilograms. Then we get x equals 7.4 times 10 to the 3 electrons. Okay, so even though the junior tutor gave us how to answer it, it was kind of confusing to read and didn't really add any of the actual values. So I'm just going to say that this solution was incorrect.